Well, now we are ready to start a program that is purely a CPM program. We have on the DEAR system some program that waits only to be executed on the Aleph system. We have the seed, just a curiosity, just to see something on the Z80 processor. But before to begin with the Z-seed, I want to show you the DPB. The DPB shows the disk system, the sector scaling, the geometry of the disk system in the emulated or Aleph virtual CPM subsystem. Aleph virtual CPM subsystem is the acronym of meaning AV-CPM. Now we can do DEAR again, and we can run some basic program just to show the interfacing of the RISI program written under DOS, FreeDOS, or any commercial DOS, and the Aleph system. So we can run the basic that we have on this version, I hope. Yes, there is the MBASIC, the Microsoft BASIC. Here is our BASIC. This is the Microsoft BASIC 5.21, and now we can load our program. Just as a normal CPM system. Load file not found because is required the uppercases. I do not cut the 7th bit of the byte, so as did the old CPM. In this case, to see Italian accent like and so on. But with uppercase letters we can load this file. Alright, we can make a list to see the program listing. Yeah, now we must remember that we are on a video terminal, so we have no way to move the cursor on the screen. In the past times were used the escape sequences by the digital. The PDP-11 uses these sequences, these escape sequences, with a video terminal BT100 Z80-MMU and so on. Something like this I have done by myself for RISI. RISI has its own ANSI sequences that I have called differently. I have defined this system of sequences for moving the cursor on the screen, for clearing the screen, for making random access on the console, on the video terminal. Now, let's see some demo of this program that allows a normal Microsoft BASIC for using this feature that is added by myself. If I want to move cursor up and down on the row, I want to scroll up, down on the screen, I cannot do that because I cannot clear the screen. There is not the instruction locate of the GV basic. This is a very standard basic. So if I want to make a random access on the video terminal, I must define my sequence, my escape sequence. Now I go to list this. Yes, in this case we can see the sequences needed for clear the screen. You can see the sequences needed for a multiple scroll up, and we can see some other sequences for the RISI video terminal. Yes, here is the Goto XY. In this case we use two variables, X core, Y core, included in the $CHR of the standard basic, followed by some char del backspace, just for correcting some little error on video. Well, I'm going to execute this program. In this case, we have a string in the center of the screen. So we have an access, a random access to the terminal. We have seen as a dumb terminal write many strings in order, in a serial way. Now we can write our string in everywhere on the screen, as we can do on a normal video card. But this computer has not a video card, has only serial ports. My string, I put my name. Well, we have a scrolling down and a new access random. We can play some other demo by running now we can see some object running on the screen like a sprite of the past era video games, and so on. In this case we are executing the Microsoft BASIC in the Aleph console in a subsystem CPM, and these are the files on the disk that we can see inside the ambient of the BASIC. We return to the system. Microsoft MBASIC has a little bit of a bug. I've made a little routine in the BIOS for verify when a program exit what is the stack position. If the stack position on the exit of the program is different from the stack position at the beginning of the program, then the system put on video this message or warning telling that the program has an exit not normal, but is nothing of to be afraid. The system has detected this little anomaly of the program. Now we can see what I can do. Here is a D, an editor very strange. A D. New file, insert. Now we can insert just a message. The AD command requires the restart of the system. In this case, the BIOS detects this case of exit as a non-normal exit, because the normal exit for the Aleph virtual CPM is only one possible. Behind with a ret instruction and with a stack perfectly aligned. Now we can see Z80 command, and we can run some program DPB, no, page. Well, now we are running the Z80 program, and we are dumping from the page 1 in the subsystem of CPM the program page that we have assembled on the Aleph system. Here is the source, the binary file. We can verify on the other system that we have the same opcodes. We have the same opcodes, and we have loaded this file in CPM machine, as a source code. We have compiled this with the Aleph assembler, and we now have an executable program for CPM that we are looking with a CPM program, just as a CPM normal application. Yes. And so on. We can do the listing also with instruction disassembly. With instruction disassembly, we can see well, the CPM application, the CPM subsystem can be stopped by the supersystem, by Aleph subsystem, in each moment you want, by pressing F5 or F12. In the case of F5, we on F5 have the scan code K of the Control C. On the Control C, we have a sort of breakpoint. I show you. Now, from this program, we can exit from the system by Control C. The AV-CPM uses a breakpoint and allows you to stop the system and go to the Aleph system or reboot the CPM subsystem. You may choose S or R. If you choose R, the subsystem CPM has reloaded, just as Control plus C. Press it. If we press again Control plus C on the F5K on the keyboard, we can press S and stop for return to the main system. Into the main system, we can dump the memory page where the CPM lives. And now we can see in this page the same opcodes of the our program loaded, compiled and executed on the subsystem CPM. This was loaded by an application in the subsystem of CPM and now is viewable on this way. Alright, thank you for watching. This is just a little demonstration for the Aleph memory management unit and the Aleph system, the software, the hardware. Everything you see is made for using all the resources of the Z80. Resources that in these years are not used. The Z80 is a processor that has two sets of registers, but CPM uses only one set of registers because it was made for the Intel 8080 microprocessor. If you load again the CPM, we can see here is the banner, the starting banner, and here there are the credits of the persons that has made his rule in this AV-CPM subsystem. The BIOS was written by me. The kernel is based on the disassembly work of Clark Kelkins and is downloadable from the unofficial CPM website. All this software was made for play and educational uses only. This is the Aleph virtual CPM engine subsystem 04. Is a young version, just a baby version. And the last lines, the last of the lines of these lines tells that the BIOS subsystem disk is configured as the Apple II subsystem.